Good morning, everyone. In the previous class, we have discussed about the different types of grammars. In this class, we will be discussing about the conversion of finite automata to a regular grammar. So you are having a finite automata, that is DFA, NFA, and epsilon NFA, and that finite automata is to be converted into your grammar. So what type of a grammar? Regular grammar. So regular grammar andre type 3 grammar. So type 3 andre all the terminals should be on the right hand side, and it can have a combination of non-terminals, and on the left hand side it should be having only non-terminals. So only non-terminals irbeku, left hand side alli, right hand side alli epsilon terminals and non-terminals can be the combinations. Clear? Right? Okay. So to convert your finite automata to a regular grammar, let us see a simple procedure here. So let M, so any finite automata is represented using 5 tuples, right? So M equals to Q, alpha, transition, starting state, and the final state, where Q stands for the set of states and alpha stands for the set of input symbols, right? And let G, the grammar, regular grammar, we are constructing grammar from this DFA, which has the tuples BT, PS. So any grammar having this any DFA having these attributes which are to be converted to a given grammar should follow two rules. So yeah rule. First thing, if the transition between in your DFA, if there exists a transition from Q1 on A, if there is a transition of Q1 I take as Qi upon A, it moves on to Qj, then we need to introduce a production, Qi tends to Aqj. So if there is a transition from Qi upon A to Qj, then we need to introduce a production called as Qi tends to Aqj, right? See this, Qi ili A ili Qj ili. Clear? Here is one production irutte. Next, if there is a first state, starting state called as Q or Q0. If Q0 is a final state, so final state Q1, Q0 one day state ide, adu state nanige final state agide, that is starting state is itself is my final state, then introduce a production called as Q0 times epsilon. So Q0 times epsilon. Ee eradu rules ನಾವು ತಲೆಯಲ್ಲಿ ಇಟ್ಕೊಂಡ್ರೆ ನಮಗೆ ಬೇಕಾಗಿರುವಂತಹ DFA to grammar ನಾವು ಈಸಿಯಾಗಿ ಕನ್ವರ್ಟ್ ಮಾಡಬಹುದು. If there is a transition from Qi to A, then tends to Qj, then I write Qi tends to Aqj. And if the Q0 is a final state, then Q0 tends to epsilon ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ಒಂದು ಪ್ರೊಡಕ್ಷನ್ ನಾನು ಬರೀತೀನಿ. Right? Clear with this? ಅರ್ಥ ಆಯ್ತಾ? Okay. So ಇದು ಕ್ಲಿಯರ್ ಆಗಿ ಅರ್ಥ ಆಗಬೇಕಂದ್ರೆ we need to study few of the problems. So let's begin with the problem. Here the topic is finite automata to grammar. So first problem. Obtain a grammar G. Obtain a grammar G to generate a string. To generate a string consisting of any number of yes. it should be consisting of any number of A's. Okay, this is the given problem. Obtain a grammar G to generate a string consisting of any number of A's. So any number of A's. Any number of A's ಅಂದ್ರೆ ಏನು first one. So first now ಏನು ಮಾಡೋಣ? So we'll analyze this particular problem with respect to finite automata. So ಇದು finite automata ಏನು? ಅದನ್ನು draw ಮಾಡೋಣ. String consisting of any number of A's. So it can be 0 or it can be n. So there is state q0 which is start state, 0 ಅಂತಂದ್ರೆ ಅದುವೇ final state ಕೂಡ, and any number of A's ಅಂದ್ರೆ ಇದಿರುತ್ತೆ. Correct? Okay. So again on rules ಹೇಳಿದೆ ಏನಂತ ಹೇಳಿದೆ, if starting state is a final state, first introduce a epsilon. q0 tends to epsilon. And next, transition of q0 upon a tends to q0. Right? So ಇದನ್ನ ಹಾಗೆ ನಾವು ಏನು ಬರ್ತೀವಿ, q0 tends to a q0. So how you can write your productions here now? So I consider q0 as a starting state itself, ss. So s tends to a, q0 is again a s, yes, or q0 is can also be epsilon. This is a grammar that you are going to have, right? S can be either as or s can be epsilon. So ಇದು ಹೇಗಾಗುತ್ತೆ? So let me take an example. There is a string of 3 symbols a, 3 a's. So first s tends to as, so this I'll take. Next, this is again I'll derive this production as. This s again I'll produce the same s. Next 3a completed. Next is s. This s should not be there, so I'll take epsilon, which is nothing but a. This is how we are going to derive our strings. Okay, we move on to the next problem. Obtain a grammar G to generate a string consisting of hello. Okay, next question. Obtain a grammar G to generate a string consisting of at least one A. So at least one A. So at least one A andre we'll write a DFA for it. So I have my starting state q0 upon A, it should go into q1, which acts as a final state. Right? So from q0 I am having transition from q1 on A. So 1A. So any number of A's is also it can have at least 1A and 1A is there. Any number of A's. Right? So for this we'll write a production grammar. So here, see here, transition of q0 on A is going to q1, and transition of q1 on A is moving to q1. So these productions can be written as, so in epsilon barala, epsilon ಏನಕ್ಕೆ ಬರಲ್ಲ ಅಂದ್ರೆ starting state, ಈ starting state and final state ಅಲ್ಲ, so our epsilon production ಬರಲ್ಲ. So ಇದು ಹೇಗೆ ಬರುತ್ತೆ, transition of q0 on A tends to q. So q0 tends to a q1, q1 tends to a q1, right? So q0 ನಾನು s ಅಂತ ತಗೊಳ್ಳುವ, so s tends to a, q1 ಅನ್ನ capital A ಅಂತ ತಗೊಳ್ತೀನಿ, variable capital A, and Q1 capital A tends to A. This is the required grammar. This is the required grammar. So again, here A is a variable. Last ilalva A tends to nan khali aaytu. Aವಾಗ A tends to epsilon antanu ನೀವು ಬರೀಬೇಕು. So ಬರೆದ್ರೆ ಅಂದ್ರೆ 10A 10 ಆಗಿಂದ ಮತ್ತೆ A ಬರುತ್ತೆ ನನಗೆ. ಆ A ನ epsilon ಅಂತ ಕೊಡಕ್ಕೆ ಅಲ್ಲಿ ಬರಿಬಹುದು. So ಅದರಿಂದ ಯಾವುದೇ ಆಬ್ಜೆಕ್ಷನ್ಸ್ ಇಲ್ಲ. ಬಟ್ ಸ್ಟಾರ್ಟಿಂಗ್ ಸಿಂಬಲ್ epsilon ಆಗಕ್ಕೆ ಚಾನ್ಸ್ ಇಲ್ಲ ಅಲ್ಲಿ. Clear with this? Okay? Fine. So next, obtain a grammar G to generate a string consisting of any number of A's and B's. Any number of A's and B's. So it can have either 0A, 0B. It should accept. So 0 is the accept the starting state will be my final state. Right? So any number of A's and B's. A comma B. So it is production. First starting state is starting state ಆಗಿರೋದ್ರಿಂದ starting state final state ಆಗಿರೋದ್ರಿಂದ Q0 ನ ಎಷ್ಟು ಅಂತ ತಗೊಂಡಿನಿ x tends to epsilon direct ಆಗಿ. Next, transition of Q0 on A tends to Q0. Transition of Q0 on B tends to Q0. Right? Q0 is your S. So S can be A, yes, or S can be B, yes. Clearly this. Okay, the other side related question I will give you as assignment. So that thing you try to solve. Okay. Obtain a grammar G to generate a string consisting of at least 2 A's. The first thing. Okay. We'll move on to our next question. So one more you take one more assignment question. So obtain a grammar G to generate a string consisting of even number of A's. Even number of A's. Okay? Fine. So next question. Obtain a grammar G to generate a string consisting of multiples of 3. Multiples of 3. So multiples of 3 ಅಂದ್ರೆ ಏನು? So multiples of 3 into 0 0, 3 into 1, 3, 3 into 2, 6, 9, 12 and so on. This number of A's ನನಗೆ ಇರಬೇಕು ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. ಸೊ ಅದಕ್ಕೆ ಬೇಕಾಗಿರುವಂತ ಒಂದು ಡೆಫಿನೆಟ್ ಡ್ರಾ ಮಾಡೋಣ. ಸೊ 0 ಅಂದ್ರೆ 0 ಕೂಡ ಅಕ್ಸೆಪ್ಟಬಲ್ ಅಲ್ವಾ? ಸೊ Q0 ಸ್ಟಾಟಿಕ್ ಸ್ಟೇಟ್ ಆನ್ಸರ್. ಸೊ ಇದಾದ ನಂತರ ನೆಕ್ಸ್ಟ್ ಅಕ್ಸೆಪ್ಟೆನ್ಸ್ ಏನಾಗಿರಬೇಕು? ಅಟ್ ಲೀಸ್ಟ್ 3 A ನನಗಾಗಿರಬೇಕು. 1A, so I'll take it as Q1, 2A, the 3A. Anytime you can start continuing. So ಇಲ್ಲಿ ನನಗೆ ಇದಕ್ಕೆ ಗ್ರಾಫ್ ಬರೀಬೇಕು ಅಂದ್ರೆ ನನ್ನ ಸ್ಟಾರ್ಟಿಂಗ್ ಸ್ಟೇಟ್ ನನ್ನ ಫೈನಲ್ ಸ್ಟೇಟ್ ಆಗಿದೆ. Q0 ನ ಎಷ್ಟು ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ S tends to epsilon ಡೈರೆಕ್ಟ್ ಆಗಿ ಬರೀತೀನಿ. ನೆಕ್ಸ್ಟ್ Q0, transition of Q0 on A goes to Q1, transition of Q1 on A goes to Q2, transition of Q2 on A goes to Q0. So Q1 ನ S A ಮತ್ತೆ B ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ನನ್ನ ಗ್ರಾಮರ್ ಹೇಗೆ ನಾನು ಬರೆಯಬಹುದು? So Q0 A ಇದೆಯಲ್ವಾ? So A tends to A B, sorry, Q0 ಅಂದ್ರೆ S A and Q1 ಅಂದ್ರೆ A tends to A, Q2 ಅಂದ್ರೆ B and Q2 ಅಂದ್ರೆ B tends to A, Q0 stands for yes. So this is the required grammar. The required grammar. Little tricky question with this. I'll give assignment. Try to solve over this. Obtain a grammar key to generate a string consisting of string length, equal to multiples of 3. String length equal to multiples of 3. Okay. Next we'll move to the next question. Obtain a grammar key to generate a string consisting of any number of A's and B's with at least one A. Any number of A's and B's with at least one A. For this, let me try to draw a DFA. At least one A. So one A ಅಂದ್ರೆ ನನಗೆ ಇದು ಲೇಬೇಕು. So this will be my final state. Q1, Q0, and starting state. And this is A, and any number of A and B. Any number of B's in the beginning. Right. Correct. and a grammar brand. So if you are capable of drawing your DFA, then it's easier to generate your regular grammar. Okay. First, so starting state is not my final state, hence no epsilon transition. Next, transition of Q naught on A equals to Q1. Transition of Q naught on B equals to Q naught. So next, transition of Q1 on A equals to Q1. So transition of Q1 on B equals to Q1. So let me take this as S starting state and A. So Q naught is S. So S tends to A, capital A. Next, Q naught is S. S tends to upon B, Q naught. Yes. Next, Q1. Q1 is A tends to A, and B, Q1 andre again A tends to B, A. This is the required grammar that you are going to have. And at least classically A is ever A tends to epsilon, final grammar. Okay. Next assignment question is obtain a grammar of the laboratory. Any number of A's and B's with at least one B. With at least one B. Okay, and a couple of problems I give that you take as assignment and submit in the next coming class. I'll share the answers for these things in the next classes. Next is web. Obtain a grammar key to generate a string of any number of A's and B's. Any number of A's and B's with at least one A and one B. Next, obtain grammar key to accept a language. Accept a language L equals to W. The length of the string will be mod 3 greater than 0, where W belongs to A star. Try to analyze these things and try to solve the problem. In the next class, I will be sharing the solutions for these assignment questions after you submitting. And for today's, it's quite enough. In the next class, we'll try to study about grammar to the regular expression. From a grammar to your regular expression concept will be